Hey everybody, welcome back to Java A to Z's fundamental speed training in 90-ish minutes with coding nomads. My name is Ryan Desmond, and this is part 4, section 4 of 4, where we get to use our new skills to build out a simple blackjack game. And keep in mind there's many ways to do this, so we're just going to do it in one way as fast as we can, just to demonstrate as many of the concepts that we've just covered as possible. So let's go ahead and hop right in. What we're going to do here is in the Blackjack package, we're going to create a new Java class, and I'm just going to call this entry point. And this is just going to be where our application starts off. So this will be where the main method is. And we're going to create the Blackjack game. The primary, I'm kind of seeing this as an application that could have many games, right? Not just Blackjack, but it could also have 5-card draw, 7-card draw. There could be lots of games. So we'll just go ahead and demonstrate what it's, building out one game, and you can build it out from there. So that's going to be a Blackjack game. Let's call it Blackjack. Sure. Equals new Blackjack game. So this class doesn't exist, and I am going to, what we can do is just go ahead and hit Alt-Enter, and I'll go ahead and create that class. And we'll go ahead and leave it in the same package. And then in this Blackjack game, we'll basically say Blackjack game dot play. And that'll be a new method that doesn't exist. Again, I can put my cursor in there and say Alt-Enter, create method play. And it'll just go ahead and create that empty method for me. Just as an example, we could, for instance, we could take in some input from the user. We could say, for instance, scanner equals new scanner. System.in. And so system.in, again, is just, that's it's an input stream that comes, it's kind of the most basic input stream that we get with the system class in Java, which is a byte stream. And then we could, for instance, put out a, what game would you like to play? Press enter 1 for Blackjack, 2 for 5-card draw. Three, 4, etc., etc., etc. And then we could say, int user choice equals scanner dot next int. And then, for instance, we could say if user choice equal 1, then we would play a Blackjack game. Else if user choice equal 2, then we would create an object of the 5-card draw poker game. Play, etc. So let's go ahead and jump into the Blackjack game. I'll jump into the play method. So I think with a Blackjack game, I can immediately start thinking of, especially if we're going to have 5-card draw, 7-card draw, and all these other games, that this class will extend a class called game. So extends game. And because all games have some things in common. And I'll go ahead again and create this class. Since the game class is just going to be the Blackjack game is kind of a controller, but the game class it's definitely a Pojo. So I'm going to make a new package for my Pojos. And to keep it kind of obvious, I'll call them object models. It's like the object model, the data model of the data that we're dealing with in this application. And a game is going to be in there. It'll just be a Pojo. And in this game class, I think that, what are some things that all games share? They could have and I'll make these private so we can use getters and setters. They have a name, and they have some basic rules. And we could just leave it at that for right now. All games have a name and some basic rules, and we'll keep it simple. So in the Blackjack game, in the play, as soon as we get started, one of the first things that we want to do is just set the name. And we can do this. This is a method, again, in the game class, but we're a child class of game. So I'm just going to set the name Blackjack. and then set basic rules to the player closest to 21 without going over wins. All right, so we've got a basic blackjack game. It extends. We have a parent class called game. Any other 5-card draw, et cetera, could also extend game. And the first thing they would do is say set name and set basic rules. The next thing that we're going to need in a blackjack game is we need card players, right? We're going to need cards, decks, card player, a few other things. And so let's go with card player. And we want to, it's going to be the user that plays the computer. So let's say card player computer equals new card player. And we're going to create this, but the name of this player is going to be computer. And when we get a new player, we're going to need to know their name and how much money they have or that they want to start with. And we'll just give the computer a budget of $10,000. So they always start each game with $10,000 because they're like the dealer, basically. We'll leave that blank for right now. And then we'll go ahead and create, well, it wants, I like to get rid of errors as soon as they come up. So my card player class is going to need a constructor that takes in a name and a budget. So we'll go with private string name, and, or let's call it stack value, private int stack value. And then we'll create a constructor. And again, to get that menu, I'm just holding down the control key and hitting enter. And we'll do a constructor that takes in both of those things. So now we've got a new card player. And the next thing that we need is a card player for you, for us, for the player, the user. And let's just call that user equals new card player. But in this case, we don't know the name or their stack value, their budget. So let's go ahead and overload the constructor in the card class. For some reason, I always like to put my constructors that don't take arguments or parameters above the ones that do, but I don't know that that's in any way necessary. So I'm going to say select none. And when we get when we're creating a card player where we don't know the name and stack value, that means that we need to ask the user for those values. So what I'm going to do is I'm going to create a method to do this, just so I don't put it all in the constructor. And let's say initialize new user. This is just going to be a method right here inside this card player class. I'm going to put my cursor in and say Alt-Enter, create method. And I like to put my regular methods down below my constructors. And so the first thing that we're going to do here, I'm going to want a scanner for this. We'll be using a lot of scanners in this game because it's just something we're going to play through the console. And all of them are going to take system.in as the input stream. And we're going to say, we'll just give them a welcome message. Give ourselves some space here. Hello, and welcome to Blackjack. We can have a little fun with it. We'll say, my name is computer. What is your name? And then we'll say this dot name equals scanner dot next. And I'll just show you guys something real quick. So scanner is this object of the scanner class. As soon as I use the object name, which is scanner with lowercase n, if I just say dot afterwards, all of these methods, these are all methods on the scanner class that I can get, that I can use. And so, for instance, if we look here at this next method, over here on the right where it says string, that's what this returns, right? So we used next int previously, like in the entry point class there. Here we can see has next int, it's got, and here if we see next int, for instance, it returns an int. So when we say scanner.next, it's going to return a string. And I'm just going to set that immediately to the instance variable in this class called name. And then let's say thanks. And then I'll go ahead and print out the name. And let's ask them how much money would you like to start with? And then we'll say this dot stack value equals scanner Next int. Cool. So this allows us now to initialize a card player as the computer. So the computer, we just said, we hard coded in that the computer's name is computer and they start with 10,000. And now when we create a new card player that we don't know the name and budget for, immediately in the constructor that gets called, we just call this new method initialize new user. And inside initialize new user, we ask them for their name, set it to the instance variable, then we ask them for their budget, and we set that to the instance variable. So let's go back over to the controller here. Once we've got the new players, we'll want a new deck. So deck, deck, let's say equals new deck. We're probably going to want to modify this a little later, but we can start with it here. So we don't have the deck class yet, so I'm going to go ahead and say Alt-Enter, create class deck, and I'm going to put this in the models package. And the deck has, we can have a little fun with this because the deck is going to have a private card array, right? So a deck has an array of cards. And we can actually call that the deck. And we can go ahead and initialize the initial array right here to size of 52, which is, there are 52 cards in a deck. I'll go ahead and Alt-Enter and create, oops. So see, this is an interesting thing. Right here, I just did Alt-Enter. And instead of asking me to create that new class, it automatically imported the class that it thought it was supposed to. In this case, javax.smartcardio.card, which is interesting. But we don't want that card class. So I'm just going to manually create that in this also. Card player goes up in object models. Again, it's a POJO. And then I'm going to create a new class here called card. And I'll just leave that blank for right now. And so since it's in the same package here, it just automatically has access to it. Let's also, we're going to need to load this deck full of cards, but we also are going to need to keep track of what cards in the deck have already been used. And that's going to be a number that changes. So we could use an array, but let's, just to have some fun with it, let's use an array list. And this of type integer. Remember, generics, array list is generic, and generics do not work with primitive types. So I've got to use the wrapper type integer with this. And let's call this used cards equals new array list. And you don't have to delete these curly brackets, but I normally do. Then each card has a, this could go in the card class, but I'll do it right here for right now. So there is an array of suits in a deck, right? So such as spades, hearts, diamonds, etc. So we're going to go with char array suit, and I actually made a note in this like this. Char array suit equals new char array. And because I don't know what the keys are for those on my computer, I went and got these off the internet previously so we could use them. And also just so that we can keep track of how many games have been played and have a good example of a static variable. Let's create a static variable, private static int fresh decks loaded. So basically, in between each game, we're going to reload the deck, and this number will increment. And while we're here, why don't we just go ahead and do it? So public deck. This is just a constructor. I can tell that because there's no return type, right? And the name of this method is the same exact name as the class. So constructors are a type of method, but they're unique in that you don't call them whenever you want. They automatically get called anytime a new object is created. And you know that a constructor is being called because you'll see that new keyword being used. So for instance, deck equals new deck, or deck my deck equals new deck. When you see that new keyword, that means a constructor is being called. So when we create a new deck, we want to go ahead and load it. So we'll say load fresh deck, and that'll be a method because there's going to be a bunch of code needed there. So I'll go ahead and create that, Alt-Enter. And then we also want to increment this fresh decks loaded static variable that we have. So in load fresh deck, we'll see this might take a little fudging to make work, but I'm pretty sure that we're going to need a count. So that will start at 0. And then we're going to need a couple of for loops. So I'm going to say for int, let's say x equals 0, x less than 4. And I say 4 because I want to loop. Basically, what I'm trying to do right now is initialize the deck. I want a 7 of clubs in there and a queen of diamonds and an ace of spades. I want all those decks. I want all those cards actually in there. And so there's 4 types: ace, spades, hearts, diamonds, clubs. And so that's what this x minus 4, x less than 4 is. And then x plus plus. And then we're going to have another loop inside here, which is going to be int I equals 0. Or actually 1, because the ace is actually would be the 0. So basically there's 13. We could start at 0 or and go up to less than 13, or we could start at 1 and go I less than 14, right? Because there's 13 of each suit. Ace through king of each suit is 13 cards. So I'm going to say while I starts at 1 and is less than 14, and I plus plus. And we'll basically say that if the value of I is 1, that's an ace. So if I equal 1, we'll say deck at the index of count. This is the reason I made the variable count, because I need to go all the way through all 52 indexes of this array, and neither x nor I will get me there, right? Because they're going to loop at 4 and loop at 13, or they're going to loop at 3 and at 13. So deck at the index of count equals new card. And then what I'm going to do is pass in the suit at the index of x and the value ace. So remember, suit is an array full of these characters. So when I do this, when I say suit x, for no matter how many times we loop on the inner loop, x does not change. So on this whole inner loop, when we go from 1 to 13, suit x will always be spades on the, and then once this inner loop is complete, this up here will go, x will become 1, and then suit at the index of x, which is 1, will become diamonds. And then we'll loop 13 times with suit as diamonds. Looks like the constructor for card has not yet been created. So let's go ahead and create that. And let's build out card a little bit. So card needs a char suit, a string value, and like a score value. Because ace of spades, for instance, will be the string, the value, and then 1 or 11, I think we'll just stick with 11, will be the score value. So let's do private char suit, private string value, and private int score value. And when we create a new card, we're just going to pass in the char suit and the string, oops, and the string value. And then we'll say this dot suit equals suit, and this dot value equal value. All right, we can start there. So deck equals new deck, and when we were still loading the fresh deck. So if how about if we've got a couple more cases here. So if I equals 1, it's an ace, but then if I equals 2, it's a 2. If it equals 3, it's a 3. If it equals 4, it's a 4, all the way up to 10, right? But and so we can basically just, we'll deal with that at the end. So I'm going to say otherwise else if I equal 11. And in this case, 11 will be a jack. So here I'm going to say deck at the index of count equals new card. And we'll again give it suit x. It's always going to be suit x in here. But then we'll say jack. And then else if I equal 12. deck at the index of count equals new card suit X. And this will be a queen. We can just copy this for the king. And then for all other cases, we'll just do an else. And we'll say deck at the index of count. We'll get suit X, but then it will get integer dot toString I. So for instance, if it's 9, it will, and then we could probably say 2 uppercase to make it match the other ones. So integer dot toString. So integer is the wrapper class around integer, and it will basically, in this case, it'll take the number that's currently an I, whether it be 1 or 7 or 9. Well, 1 will be ace. So if it's anything 2 through 10, it'll take that number and it'll turn it into a string, integer.toString. And that's what that would return. And then before I return it back here, I want to say, but also make it all to uppercase. And so, and then after we go around the inner loop, after every inner loop, we're going to need to increment count, right? Because we want, so basically this is going to load the deck up with ace through king on all the suits. And it's using that count variable to to increment all the way through the array. I'll clean this up a little bit. I'll probably come back here. But all right, let's go back over to the blackjack game. Now we've created the deck. The next thing that we're going to do is, I guess once we have the users and the deck, we can kind of start playing. And I think that we should do this in a loop. And we'll make this a do while loop. And for right now, just so there's no error, I'll just say while true, which will just be basically an infinite loop. But I'll come back and change that momentarily. And now already I'm thinking that we should have this deck new deck in here. So I'm going to say deck equals new deck. So with every game, because I'm basically seeing this will be like rounds of 21, right? And for every round, they'll get a fresh deck. And again, anytime we create a new deck, this load fresh deck will be run, and this new deck object will have a totally fresh deck of cards. And it'll also have a fresh array list of used cards, meaning there'll be nothing in there. So we'll be starting from scratch. And then let's go ahead and we'll just print out something. Let's communicate with the user saying, and since we're going to be doing a lot of since we're going to be doing a lot of communication to the user, I'm going to put basically everything on a new line. So I'm going to say game number, and then plus, what is it, deck dot I need to create some getters and setters over here. So I'll just create them for all of them. So then I'm going to say deck dot get fresh decks loaded, right? Because every time the new the keyword is used and an object of this deck is created, this static variable, which all objects share, will get incremented. So we'll always know basically what, and we should maybe start this. Yeah, this will work. So game number, and then on the first one, it'll be 1. And then the second game, it'll be 2, just so we can keep a track. And then to have a little fun with it, let's go ahead and print out some ASCII art, just to make it a little more interesting on the console. So we're going to say print ASCII art, and this is just going to be a method that we run. And again, this is something that I made a little note on. And all this method is going to do is print out, let's play some blackjack. So right now, let's see, could we run this? Let's go to entry point and just go ahead and run it. See where we're at. So what game would you like to play? Enter 1 for blackjack. So let's go blackjack. Okay, hello and welcome to Blackjack. My name is Computer. What is your name? Ryan. Thanks, Ryan. How much money would you like to start with? Let's say $100. Oh, I got myself. Oh, it's that while loop. I'm in that infinite while loop. So I got to stop it. But you can see you get the gist. And I'll go ahead. Wow. So it looped 386,000 times in that in that few seconds. Shows you how fast this stuff can move. All right, so after we printed out the ASCII art, the first thing that we need to do with every game is bet. And since I know this is gonna be several lines of code and I'm gonna need to use it over and over and over again, let's go ahead and create a handle bets method. And this is actually something which every card game needs to be able to handle bets, right? So something that I think we could do here to also demonstrate interfaces is that we could have a card game interface. So I'm going to go ahead and so basically I'm gonna have this Blackjack game also implement card game. Implements card game. I'm gonna go ahead and create interface card game. And just to clean this up a little bit, I'm gonna put my controller classes in their own package. So for instance, the entry point and the Blackjack game are kind of like controller classes. And then all of these other ones, card, deck, card, they're pojos. So in this card game interface, I'm just gonna have we can start with two things that methods that need to exist in every card game, and that's deal and handle bets, or you could call them whatever you want, but you need a way to deal and you need a way to bet in any card game. So I'm going to make these both void abstract methods. One's going to be called deal, and it's going to, when we deal, we need to know who we're dealing to and from what deck we're dealing from, right? So this is going to be card player, we'll call it player, and deck. Because when we deal, again, we're tracking the used cards in that deck. So anytime we deal a card, we need to also be able to track it in the deck. And then public void handle bets. It's just what I'm calling it. And then this will also take a card player, and I think that's it. So immediately now when we go back to the Blackjack game, we're going to have an error because it's telling us, if we hover over it, that class Blackjack game must either be declared abstract or implement abstract methods handle bets. So as well as deal. So let's just go ahead, and oftentimes you can get a little, there we go. I'm going to say implement methods, both of them. So all it does is just give me these two empty methods. And so now we have a handle bets method, which I can call right here. I'm going to say handle bets. And I'll pass in the user because the computer doesn't necessarily need to bet. And then in the handle bets method, again, we're going to need to communicate with the user. So there's a lot of scanners going on here. We could make the scanner a global variable and just keep reusing it, but I'm not. I don't know. I just generally stay away from global variables unless I really need them. And let's just go ahead and ask the user how much they want to bet. So how much, again, this \n basically just means new line. So basically every time I print out a new line, I'm just making sure that there's a blank line above it. It'll make everything a little easier to read. So I'm going to say, how much would you like to bet on this game? How much would you like to bet on this game? And then we could also tell them how much they currently have, right? So sout, in this case, why don't we keep these two lines together because they kind of go together, but I'll say or how about you're currently holding, and then I'll say player dot. Let's go look at the card player. Yeah, we need getters and setters here too. Because these variables are private, I can't access them outside of this class. And again, this is something about access modifiers that we actually didn't really touch in the 90-ish minutes. But access public means it can be accessed anywhere. Private means it can only be accessed in the same package or from a class that, so this is protected, means it can only be accessed in the same, by another class in the same package, or in another class that inherits from this class, from class X that has a protected variable. And then private means it can only be accessed from within this class. And default, if you don't put anything, public, private, protected, is basically just like protected. It means it's only accessible from other classes within the same package, but it's not accessible by classes that inherit or extend this class, class X. So often what you see there are getters and setters. And it seems a little redundant, like why do we have to do this? It's basically, it gives us a way to basically do some validation. You know, let's say, does this person, if they're trying to set the speed of a car to 100,000. Like that's not right. They shouldn't be able to do that. So you shouldn't be able to just say like Honda.speed equal 1,000. You should instead, you'll make that speed variable private, and you'll say Honda.setSpeed 1,000. And then in the setSpeed method, there would be something like if speed greater than equal to 0 and less than equal to 120, or let's say 200 or something if it's a sports car, then go ahead and set the speed. Otherwise, let the user know that that's an invalid input. So over here now I'm going to say player dot get stack value. And since this is money, put that $sign on there, and I'll say worth of chips. And then we'll say int bet equals scanner dot next int. And then we have to do a little data check here. Like, what if they put in that they want to bet 10,000 and they're only holding $10? So let's do a quick if bet less than or equal to user dot get player dot get stack value. Then there's also the case that they're going all in. So I'm going to say if bet equal player dot get stack value. Let's let them know, like, oh, we realize they're going all in. So we're going to say going, we could throw some slang in there, going all in, eh? Otherwise, either way, as long as it's less than or equal to their current stack value, we'll say player dot, actually, we need a way to track, we don't have a way to track current bet, so we'll say, do we have a way to track current bet? Go again. So we need two things. We need a way to track their bet, so private int bet, and this will just be something that changes all over the place. And then we also need a way to hold their hand, so private array list, and this will be of cards. We'll call it hand equals new array list. We can just go ahead and create that. So here we'll say player dot set. Oh, need the getters and setters still. Player dot set bet bet. Otherwise, so this is the else on this. If bet less than equal to player dot get stack value, then we'll go inside this if statement and do these things here. Otherwise, that means they said they want to bet more than they've got. And so if they're going to try to be putting in numbers more than they got, let's just go ahead and ask them, just let them know. So we'll say sout, sorry, pal, you can't bet more than you got. Please bet something less than, and we'll just tell them player dot get stack value. And then we can just take in again. Well, still we need to. So we'll ask them again. How much would you like to bet? And let's put some new lines in here. And then we'll say bet equals scanner dot next int. And we still need to make sure that they didn't say 10,000 again. So why don't we say, well, and we might need to do this over and over again. So why don't we put this in a do while loop, and we can say while bet is less than or equal to, why don't we say greater than or equal to, keep saying user, player dot get stack value. while bet is greater than or equal to player.getStackValue, keep looping and telling them that you're sorry, you can't bet more than they got. And then once they're done, once they get out of there, meaning that they put in a bet that is less than or equal to their current stack value, then we can say player.setBet bet. Right? So we might have to come back and play with this, but I'm basically thinking as long as the bet they put in is less than or equal to what they currently are holding, we do a quick all-in check just to, and so here's a little thing. If you want to put actual quotes in your messages, you have to escape them. It's called an escape character for that backslash. So I'm going to say going all in, right, in quotes there. Otherwise, I'm going to loop and say, sorry, pal, you can't bet more than you got. Please bet something less than whatever they have, and ask them. And then we say bet equals scanner.nextInt. And while bet is greater than or equal to player.getStackValue, so their current money, just keep looping and asking them that. Once we're done, that means, once they put in a bet that's less than or equal to the stack value, then we'll leave the loop and let it go ahead and set the bet. All right, so let's get back up here to where we were. So we've handled the bets. The next thing that we need to do is deal cards. And I think what we'll do here is deal initial cards. And we'll pass in the user, computer, and the deck. And this is a new method. And in deal initial cards, I think we need just its own, deal method here, which we've already got. And we'll pass in the user and the deck. And then we'll hit the deal on the computer and the deck, right? Because we have to track the cards for each that are being used in each deck. And then we'll hit the user again. And then we'll hit the computer again. Right, so this is just going to deal a card to the user, deal a card to the computer, deal a card to the user, deal a card to the computer. And before we get too far on here, let's go ahead and build out that deal method. So for the deal method, we want a random number between 1 and 52. And Java has a few ways you can do this, but let's just say int random num equals, actually, let's put this in a method, get random. We're going to say get random card, and we're going to pass in the deck. And so what we're doing here is we're splitting all this logic into individual methods so that it basically stays concise and reusable. So in this get random card, the first thing that we're going to do is we create an object of this class called random, which comes with the Java language, equals new random. And I'll import that, Alt Enter. And then I'm going to say int n equals rand.nextInt. And then you have to put the lower and upper bounds here. So I'm going to say 51 plus 0. And that'll give me a number in between basically 0 and 51. So it'll give me 50, which is 52 total numbers, which is the right number that we need for the deck. And then before I return this, I need to make sure that this hasn't been used. So I want to say while, and I'm going to put this will be a method inside the deck class that'll check if the card is used. So I'll say while deck.is card used, and I'll pass in the number. And then I'll fill out that is card used, but then if it's used, then I just need to set it ask for a new number, ask for a new number, ask for a new number. And then once I get out of that, then I'll say deck.get used cards, which is an array list, which has a method called add on it, and I'll just add in that number. And then I'll return this. So here in this is card used method, we are going to just check the used cards array list. And if that number is in there, that means that card in that spot has already been used. So I'm just going to say if used cards dot contains value return true, else return false. So this just says if the used card's array list contains this value, then return true, meaning yes, this card is used. Otherwise, return false. So here, while deck.isCardUsed, I'll just keep checking to see if that number has already been used. Just keep looping, get a new number loop, and it's guaranteed to give us a number between 0 and 51, inclusively, because 0 is an ace or 1 is an ace. Basically, I just need any number for the index that's up to 52, the length of 52. So the last index in an array of 52 is actually 51. All right, so we'll go back up to this deal method here. And I'll say card, let's say player card, or how about just card equals new. Actually, we'll do deck.get card at. So this will be a new method too. And we'll pass in the random number that we just got. And let's just go ahead and create that. So in the get card at, we are going to return the card at the index of, so we'll say return deck at the index of random num. Remember, and deck is fully loaded with cards. So because when we said load fresh deck, we loaded up this deck with new cards. So when we say get card at, it'll just return the card at that index. So card equals get card at, and then we'll say player dot get hand dot add card. So we're basically just adding that card to the player's hand. If that makes sense. All right, I think that does it for the initial deal method. And I think all we need to do, we should tell everybody what they got. So let's just do some printing here. Sout, and I want to make this super obvious to the user, so I'm gonna make like a line break here. And then we'll say Sout, your first card is plus user dot get hand dot get the element at the index of 0. So that's because they have two cards, right, in their hand right now. One at the index of 0 and one at the index of 1. Those are added in there by the dot add method when we said deal right here. So we're going to print out dot get at and then let's make this, I could say .toString, but that's not going to be very pretty. So let's make it a custom toString method, which will print it out nice and pretty. So I'll go ahead and create that. And in the custom toString method, I'm just going to say return suit plus value plus suit. So that'll be like, it'll print out the club symbol, then a 4, then the club symbol. So it kind of looks kind of nice. And then we're going to print out the user's second card. So I'll just do that again. Your second card. But this one will be at the first index. And then let's go ahead and make another break here. And we'll also print out the computer's cards. So this will be computer dot get hand we'll make it like the computer is talking to the user. Oh, and the second card goes face down. All right, so now we've dealed out the initial cards and we have shown them to the user. So let's see, let's make I'll say int count equals 0 just for a moment, and then I'll say while count less than 1, right here. Just so we don't have that infinite loop, I'm gonna say count plus plus. And let's see if we can run this again. So see here, this still says entry point. So if I hit this green arrow, it'll hit the main method in that entry point class. So we're gonna play one for Blackjack. My name is Ryan. I'd like to start with $100. Oh, 1,000. All right, game one. Let's play some Blackjack. How much would you like to bet on this game? You're currently holding 1,000 worth of chips. Let's go with 100. All right, my first card is a 7 of clubs. My second card is a jack. And then I'll get rid of this extra line here. And then the computer's first card is a 6 of spades, and the second card is face down. So cool, this looks good. And then it stopped. How do we get rid of that extra space? Maybe it's this one. All right, so that gets us where we've got initial cards dealt with, and now we need to basically check to see if the players want more cards. So I'm gonna go ahead. So after we've dealt initial cards, what we need to do is keep looping, and we could go back and forth since there's just one player, we'll let the player basically hit for as many cards as they want in a row. So we'll just say, I'm going to purposely create an infinite loop here. I'm going to say while true, if, and I'm going to create a method here called check for hit, and I'm going to pass the user. Then we'll deal them another card. So user and deck. So I need to create this check for hit method. And this is just going to see, like, are they based on their current score, should they bet, or should they get another card? So the first thing that we need to do is figure out what their current score is. So we'll say int current score equals, and I'll create a method for this called analyze hand. That'll take in like the player. And in analyze hand, int current score equals 0, start at 0. And then for each card in their hand, for card C in user.getHand, we'll say current score plus equal, and then we'll say C dot, we need to get like some kind of score value for each card, get score value, which I don't think exists yet. And so we'll go ahead and create that. And in the get score value, basically, here's a good opportunity to use some try catch, because the score value is either a number like 2, 7, 10, or it's ace, queen, jack. So we're going to do this with a try catch. So I'll say try, because the score, remember that this method returns an int. So I'm going to say try to return integer dot value of value. Remember, value is the string value of the card. But if it's not an integer, if it's not 7 or 2 or 9, or let's say it says ace, there is no integer dot value of ace. So then I'm going to catch it, and we'll say, I'll just catch the widest exception. And then I'll say if, so the tricky part here is that a jack, queen, king are all worth 10, but an ace is worth 1 and 11. And I'm just going to punt on that 1 and 11 complexity and make an ace worth 11. So I'm going to say if, let's say value dot equals ignore case ace. All this is doing is to check whether the value, because strings are not equal. Like a string that let's say I had a string that said hello, and I have another string that also says hello. If I do equal on them, I'm not guaranteed for that to come back true, even though both of those strings are the word hello. They're not guaranteed to equal each other because they're objects, not primitive types. So because of that, we use this method like equals, dot equals, or dot equals in our case when we're dealing with strings. And then, so if it is an ace, I'm going to return 11. Otherwise, I'm going to return 10, because that means it's not 2 through 10. The card value is not 2 through 10. And it's not an ace, so that means it's a jack, queen, or a king, and all of those are worth 10. So therefore, we'll return 10. Cool. Current get score value. And then once we've looped through all the cards and incremented that, we can just say return current score. Cool. Okay, so we've got the current score of the user, and we're going to be asking the user basically if they want, we're going to be telling them what their hand is and what it's worth, and then we're going to be asking them if they want another card. And for the computer, we'll just make the decision ourselves. Basically, like if the score is, for the computer, if the score is less than or equal to 16, we'll say hit. And then we'll let the user choose on their own. So I'm going to say if not user dot get name dot equals ignore case computer. So if this is not the computer, that's a long way to go about it. But if this is not the computer, the current user that got, the current card player, I should say, that got passed in here, then we'll go ahead and ask them sout do a new line here and let them know the current score of your hand is plus current score, and close out those. And then basically just ask them would they like another card. Would you like another card? And then we'll say press, how about, and I have to do escape character here, press Y. Because if I want these quotes to actually show up in the message, I have to escape them for yes. And for no. So that'll basically, they'll just put in a yes or a no, a Y or a no, an N for yes or no. And then we can just take that in. We'll say string response equals scanner. Oh, looks like we need another scanner. Whether or not we should make this scanner a global variable and have all the methods use the same one, or whether each method should have its own and all the scanners get garbage collected. I'm honestly ambivalent as to which way. It's more about, I think that having one around for the entire time would probably be the way I would go, unless somebody gave me a good argument otherwise. So I'm going to say string response equals scanner, even though in this one we're creating a new one each method. Scanner dot next. And then we'll go ahead and check what they gave me. So if response dot equals ignore case Y, return true, right? That means they want another card. Otherwise, return false. No, I do not want another card. Okay, so that's, I think that handles the user. That's not the computer. Now we also need to handle the computer. So then we're going to say else if current score less than equal to 16, then we'll return, this is, that means this is the computer, return true, else they are greater than 16 already, else return false. All right, so that's the check for hit method, whether or not they should get another card. And so that'll basically loop and loop and loop on the user, giving them as many cards as they want until they say no. And then we'll do basically, if they return true, if check for hit user, then we'll deal them another card. Else, if it returns false, then we'll break out of this while loop. This is a keyword we didn't really cover in loops, but there's break, which means to break out of the nearest loop. There's continue, which means to force an early iteration of the loop as well. And then there's return, but we've talked about return. That leaves a message. Now let's do the same exact thing for the computer. But instead of passing the user, we'll pass the computer. And instead of dealing to the user, we'll deal to the computer. Cool. So now we have printed out the game, we printed out the ASCII art, we've handled the bets, we've dealt the initial cards, we've seen if the user wants any more cards, we've seen if the computer wants any more cards. The last thing that we need to do, I'm going to skip over like splitting hands and doubling down and all that kind of stuff. Now we're just going to score the hands. So let's say score hands, and we'll pass both players, the user and the computer. And in this score hands, I think this one's gonna have a little, this one's gonna be a little verbose. All right, so the first thing that we need to do is figure out the computer, the current score of the computer and the current score of the user. So int computer score equals, and we have a method that can do this already called analyze hand, and we'll pass in the computer. And then we'll say int, we're going back and forth between user and player, but hopefully that's not too confusing. Int user score equals analyze hand user. And then I'm also going to want to figure out basically the difference, like basically who's got a larger difference from 21. So I'll say int computer diff equal 21 minus computer score, and int user diff equals 21 minus user score. And this is just going to tell me, you know, computer diff might be 3 and user diff might be 2. That means that the user won, basically. All right, so let's go ahead and print out the computer's hand. So I'm going to say string. Well, we're not going to print it out. I'll just put it in memory right now. So string computer hand equals computer.getHand.toString, and we'll see how pretty that prints out. I'm also going to I know that we're going to have a lot of output that we deal with right here, so I'm just going to create this output variable. And now we need to figure out the score. So if computer score equal 21, and I'm using the short circuit and there, and I'm going to say and user score equal 21. That means we tied. Then we'll print out, actually, we'll just use this output variable, say output equals, actually, then you tied. And we'll say what everybody got. I, computer, got scored. And with what cards? With that computer hand. Right, so because there's going to be lots of different ones, rather than keep typing out a couple of things, we're just going to use this computer score and this computer hand variable, which has the hand out computer.getHand, which is an array list, .toString. And so let's go into that getHand. GetHand returns cards. To cards, I need a nice toString value in here actually, so so that this prints out nicely. ToString again just returns a string that describes this particular instance of an object. All right, else. Let's say we didn't tie, but else if. So else if computer score equal 21. So you didn't tie and the computer got 21, that means you lost. So, oh wait, before we do that, we need to handle the bets. So I'm going to say user.set stack value equal to user.get stack value minus user.get bet over 2. Because I think when you tie, you get half your bet back, right? I could be wrong there. But so I'm going to say user.get bet divided by 2, and that's in its own parentheses. So it's user.get, I'm going to say user.set stack value, and then whatever the value of their stack currently is, minus half of their bet. If you lose, okay, so output is going to be, you lose, so sorry. iComputer, let's say we know what this one is. I landed 21 with, and then their hand. And then we need to, again, update the user.set stack value equals user.get stack value minus the current bet, user.get bet. Else if let's say the computer doesn't have 21, we didn't tie, the computer doesn't have 21, but my hand, your hand is greater than 21, so we busted. So if user score greater than 21, then we'll say output equal you busted, and sorry about that. And one thing we should probably be doing is print their chimp balance after every one of these things, which is one line of code that we do over and over again. So I might just make it its own method. So we'll say, again, we need to update their stack. And then here, I'll do this for the first time, print chip balance. How about print user chip balance? I'll take in the user. And for print chip balance, it's going to be really simple. It's just going to say what their current, we're just going to print out sout. You've got, you've currently got $ plus user dot get stack value worth of chips. And then we're going to print that out after every game they've played. So we let them know after every game they played, else, this is if, else if. We'll let them know what how much they still have. So all right, so now else if, let's say that you didn't bust, but the computer got closer to 21 than you did. So else if user diff greater than computer diff, and I'll say and computer diff is greater than or equal to 0. So that's because computer diff is greater than or equal to 0. That's because if the computer got 24 and we did this computer diff right here, 21 minus 24 is a negative number, which means they actually went over, right? So as long as their diff is smaller than user diff and a positive number, that means they won. So we'll print out sout, so sad, you lose. And I computer, have some consistency here. I computers scored plus computer score with plus computer hand. And we need to do these same two things. We need to update their bet and print out their balance. Okay, so what in the odd case that we win? So else if user diff is less than computer diff. And we should probably say that and computer and user diff greater than or equal to 0. Same rules apply. The diff, well, I guess if our user score is over 21, that already got handled here. So we actually don't need to do this. If user diff less than computer diff, then we win. And we want to be putting new lines in here too. So we're going to do sout, you win. I computer scored, and I think this is basically the same. And now when a user, let's just say like they, I don't know what we will, let's say plus, instead of minus the user bet, we'll say plus user bet times 3 or something. Give them some good news, and then we'll print their balance. And then I think the last case is just to make sure, and this might be unnecessary honestly, but if computer score, if we get through all of these things and we're still here, if computer score is over 21, then that means the computer busted, and else you win, I computer busted. And we'll go ahead and times that by 3. And then the last thing that we'll do is, I moved over from output equal to system.out.println. So let's get back to that. So output equal. So then we'll print out outputs. And if we want to, just to demonstrate I/O, we could write this output to file. So we'll say write output to file and pass that output. And go ahead and create this method really quick. All right, in write output to file, we will create a buffered writer. And we'll use a try with resources. So I'll say try, and then inside parentheses, I'll say buffered writer, BW equals new buffered writer. And then this is going to take in a new file writer. And the file writer is going to take in a path. I'll go /user /Ryan Desmond /documents /webinar /Blackjack results.txt. And then with the buffered writer, it has a second variable you can pass, which is true, which means append to file. And let's see, unhandled exceptions. Let's get that caught. Add catch clauses. And then I'm just going to say bw.write. Make sure we get some fresh spaces between each one. And then I'll say plus get name. So this is the name of the game. And then bw.write \n and plus get basic rules. And then bw.write output. And then that should handle that. Let's see here. What else? Are we missing anything? So then, while count less than 1. So we want to actually keep playing this game so long as the user wants to keep playing. So what we need to do is check if the user wants to keep playing. So I'm going to say while continue playing, which is like a method that we're going to create. And we'll pass in the user and I don't know that we need the computer. Go ahead and, oh yeah, because if they want to continue playing, we're going to want to wipe the, deck and the hands of both players. So I'll create this method, create method continue playing. Okay, so if a user is going to continue playing, the first thing that we need to check is whether or not they have any money left. So I'm going to say if user dot get stack value is less than 1. So anything less than $1, they can't play anymore. We're just going to say sout /n. Sorry, pal, you're out of cash. Time to go. Goodbye. And then return false, right? Because this method returns a Boolean condition. There. Otherwise, else. Actually, this isn't an else, this is just a quality check. All right, so we'll say sout, that was game number plus deck dot plus, oh, it's static, deck dot get fresh decks loaded. Would you like to play another game? And then again, I'm going to do that. Press or enter Y for yes and N for no. I'm just going to go ahead and hit enter there so that we can see it all on one line. And then take in their input. So, and apparently we need a scanner here. Scanner equals new scanner system.in. And then I'm going to say string another game equals scanner.next. And then we need to check what they gave us. So if another game dot equals ignored case y, then we need to we need to clear everybody's hands. So I'm going to say user dot get hand dot clear. Just makes it simple enough. And then computer dot get hand dot clear. And then return true. And otherwise, say thanks for playing. And would be cool to print out, well, maybe we can do that afterwards, but print out their final, else return false. We could say like, sorry to see you leave. And let's see, I think that'll more or less do it. We got a couple of bugs lying around. Let's computer hand, what's going on here? We need another. We don't need that. All right, so then the last thing that we would do is we keep looping while they want to continue playing, but if they don't want to continue playing, then let's print out. We can, and we kind of just did that, but we can say, thanks again for playing Blackjack with me. You're walking away with and $, user dot get stuck value. In chips. And then we could kind of tease them a little bit. And here we'll say if their stack value is if they ran out of cash, so if user dot get stack value equals 0, we could talk a little smack and say, Sout, I thought you were a pro. Where'd all your money go? And then otherwise, we'll just say goodbye. And now down in this, in the continue playing method, so we don't get the, I'm not going to say that. It's a little redundant. All right, I think we might be ready to play. So let's go ahead and get, I'm sure there's probably some bugs in here. All right, so we're going to play 1 for Blackjack. And my name is Computer. What is your name? My name is Ryan. Thanks, Ryan. How much money would you like to start with? Let's go with $100. All right, so how much would you like to bet on this game? I'm currently holding $100. Let's go with $10. The score of my hand is 14. My first card is a 3 of hearts. My second card is an ace of spades. Would I like another card? I'm going to go with yes. 24, I busted. Dang. You busted. So I've currently got $90 worth of chips. You busted. Sorry about that. That was game number 1. Would you like to play another game? Definitely. Currently got $90 worth of chips. Let's up the ante to $40. Oh, and I bust out of the gate with, oh, I wouldn't if I had dealt with this aces having 1 or 11. This could have been a good hand. That being said, no, I don't want another card. That was game number 2. I've currently got $50 worth of chips. Yes, I would like to play another game. Let's bet 40 again. My hand is 12. Yes, I would like another card. 16. Ooh, it's a gamble, but you don't win with 16. Yes. 20. Nice. No, I don't want another card. I lose. Current computer landed 21 with a queen of clubs and an ace of spades. Dang, that's rough. Yes, I would like to play another game. I've got 10. Let's go all in. And it should have told us, yep, going all in, eh? I can make this bigger. My current score is 14. Let's do this. I busted. I'm out. And sorry, Pa. This should say pal. You're out of cash. Time to go. Goodbye. Thanks again for playing Blackjack with me. You're walking out of here with 0 chips. I thought you were a pro. Where'd all your money go? Goodbye. It's a little rough. He's kind of got a little attitude, this computer player. And that's about it. I think we moved really, really fast here, and I'm sure there's plenty of things to be confused about. But welcome to understanding Java fundamentals, basically from A to Z, and how to create a Blackjack game. Hopefully, just about everything that we did in here was relatively reminiscent or familiar with the things that we just talked about in the webinar series. And if you've got any questions or you're interested in reaching out, please feel free. And it's been a pleasure, and I look forward to chatting with you all soon.